Right, here we go, the fourth in our series of what might come up in the next exam paper in GCSE Maths 9 to 1. Declan ran a distance of 200 metres in a time of 26.2. The distance, is measured to the nearest 10 metres, and the time was measured to the nearest tenth of a second. Work out the upper bound for Declan's average speed. So let's work out our boundary values for each of these. So the 200 metres, and this could be anything, if it's to the nearest 10 metres, between 205 metres and 195 metres. Sorry, wrong way round. Let's just rub that out and make that correct, because actually it's not less than or equal to 205, it's less than 205, because 205 you round up. 26.2 is to the nearest tenth of a second, so it will be less than 26.25. and it will be greater than 26.15. Now we want to get his average speed, so it's in meters per second, so therefore we're going to do distance divided by time. His average speed is equal to the distance travelled divided by the time it's taken. So to make this the upper bound, we want the maximum value of this and we want the minimum value of this. So therefore his upper bound will equal distance maximum, well that's going to be the 205, and we're going to divide by the time minimum, which is 26.15. So we got 205 divided by 26.15. So we're going to do 205 divided by 26.15. and that gives us 7.83 what was that? 7.839381. So that will do for accuracy for this. Generally, normally give the whole calculator display. This is probably plenty for this for now. Right, we want to solve this equation. Y squared plus 9y plus 2 equals 8y plus 58. Well, it's a quadratic, so let's get everything on the same side. So take away the 8y, we get y squared plus y is equal to, and then we're going to take away the 58, so we're going to have minus 56. 58 from 2 is 56 equals 0. So we want to find two numbers that multiply together to give us minus 56. If we're going to factorise it, I'm not sure this is easy to factorise, because we've got 7 and 8. Yes, it is 7 and 8. Sorry, brain's not in gear. So 7 and 8. So and we want to get just one lot of y. So we want the 8 to be positive and bigger, and we want minus 7. So we know that that equals 0. So therefore, either this equals 0 or this equals 0. Okay, two numbers times together equal 0. One must equal 0. So y minus 7 equals 0 or y plus 8 equals 0. I think it's a good habit to write them like that. So therefore, y equals 7 or y equals minus 8. So we've got minus 7 or minus 8. Let's see if we can factorise this one. It may be possible, it may not. It doesn't tell us we can factorise it. I'm going to have a go anyway. So we got 4, it looks like it is actually. So you get 4 times 5 gives you 20, and 1 times x gives you 1x. So subtract that and add that, and you'll get your plus 19x, because you get minus 1x that way and 20x that way. So therefore 5x minus 1 equals 0, or x plus 4 equals 0, because this all equals 0. So if we solve this one, we get add 1, divide by 5, x is 1/5, or solve this one, x is going to equal minus 4. Okay, so that one implies that x equals 1/5, and this one implies that x equals 4. Right, now we want to solve the equation x squared minus 2x minus 9 equals 0. Give your answer to 2 decimal places. So straight away, it's telling us we've either got to complete the square or use a quadratic formula. I'm lazy and I find completing the square quicker. So I'm going to get x minus 1 all squared. And that gives me the minus 2x. I want to get the minus 9. So therefore, I've got to take away the 1, because I'm going to get 1 squared. And then take away another 9 equals 0. So I get x minus 1 all squared minus 10 equals 0. So x minus 1 all squared equals 10. So x minus 1 equals plus or minus the square root of 10. So x equals minus 1 plus or minus the square root of 10. Alternatively, you could use the quadratic formula. So we get minus b, which is 2, plus or minus the square root of b squared, which is 4, minus 4 times a times c. Well, a is 1, because it's 1 lot of x squared, and c is minus 9. So we're going to get minus 4 times minus 9, which is plus 36, all over 2a. So that's equal to x. Oops, I made a mistake back here. I've just realised it's good that I did this to check. So 2 divided by 2 is 1, plus or minus. Now this is 40 over 2, which is also the same as, if you take this 2 into the square root, we have to square it. So therefore we get 40 divided by 4, which is 10. So it's 1 plus or minus 10. When I went from this line to this line, I should have added 1. So there should not be a plus 1 there. So if I get my calculator, because it does ask us to so many decimal places, so we can do 1 plus the square root of 10. Let's get a new line. 1 plus the square root of 10. That gives 4.1622. 2 decimal places, that's 4.16. 4.16. And if we do that again, we get, let's just go back here and just change it to a minus. We get minus 2.16. for our other answer. Right, let's just carry on from there. Right, we've got an nth term of a sequence is 4n minus 7. Write down the first 3 terms as sequence. So when n is 1, when n equals 1, we're going to get 4 times 1 is 4 minus 7 is minus 3. Then when n equals 2, we're going to get 8 minus 7, which is 1. And when n is 3, we're going to get 12 minus 7, which is 5. Now, because this is 4n, our terms should go up by 4 each time, which they do. So it's a good way to check. And I've just given away the answer to what's the difference between the 150th and the 151st term. Because it says 4n, every time n goes up by 1, the term goes up by 4, because we're timesing by 4. So therefore, the difference between these is 4. And alternatively, if you really wanted to, you could do 4 times 151 minus 7, take away 4 times 150 minus 7, and then you've got to take all that away. So let's just rub that out and put it nicely. So minus 7, and then we can see that the 7s will cancel, and then you got basically 4 times 151 minus 150. Nice bit of algebra here. So that gives you 4 times 1, which is 4. So we can see it all agrees. The last term of the sequence is 393. How many terms in this sequence? So 393 must equal 4n minus 7. So therefore 400 will equal 4n. So therefore n will equal 100. Next one. Here are the first 5 terms of quadratic sequence. So we know that it's going to be something like an squared plus bn plus c. And there's lots of ways to do this question. You could just try writing out the square numbers and see how it compares, or you could learn the by rote method of knowing what everything does. And we know, let's just write out the square numbers and see what we get. Will that be useful? Now I'm going to use this method of doing it. Okay, so I am going to look at the differences. So my differences here, 9 from 17 is 8, 17 from 29 is 12, 29 from 45 is 16. We might spot a pattern going on here, and then we get 20, and the differences here is 4. And the reason why I did this, it just makes an easy way of getting A, because A is always half of the 4. The 4 is double A, so therefore A will equal 2. Okay, and there's lots of ways you can go about finding the rest. If you know this off by heart, we go backwards, we get 4, we can find the noughth term is 5, and the noughth term must be what C is, because if n is naught, these two bits are equal to 0. So we know that C equals 5. Okay, and we know if we've got the noughth term is always going to be C, and the first term is going to be A plus B plus C, then we know the difference between the first and the noughth term must be A plus B. So the difference between the first and noughth term, which is 4, must be A plus B. So in this case, B is going to be 0, because we know that A plus B must equal 4. Not 0. So A is 2, B will therefore be equal to 2. So this is quite a useful way of doing this question. We can see that's equal to that, and therefore we can find B. So we've got our quadratic. We've got it's 2n squared plus 2n plus 5. Now I think it's a good idea to check that. Let's put 1 in. So you get 2 plus 2 is 4, 5 is 9. That worked. Put 2 in. 2 squared is 4, times by 2 is 8. Plus 2 times 2 is 4, 8 plus 4 is 12, plus 5 is 17. And so it's looking good. I've checked it in 2 of them. That's probably going to be okay. Shown below is an isosceles triangle. Each side is measured in centimetres. Find the perimeter of the triangle. Okay, so it's an isosceles triangle. We know that these sides are equal, so we know that 3x minus 1 must equal x plus 9. So therefore 2x must equal 10. I've taken this x off both sides, taken it off the 3x to get 2x, and I've added minus 1 onto both sides to get the plus 9 to go to 10. So x equals 5. So therefore the perimeter must equal 3x minus 1 plus x plus 9 plus x plus 1. So that's 5x plus 9. So that's going to be 5 times 5 is 25 plus 9 is 34 centimetres. Right, we've got an inequalities question. We want to find the region labelled R satisfies 3 inequalities. So here's our region R. Here we go. And it's going to satisfy 3 inequalities. So we need to find the equation of these lines that are boundaries first. That's our starting point. So we know that this one is x equals 2, because wherever we are on here, x equals 2. We know here y equals 6. And this one, we can use y equals mx plus c to find this, and the gradient, how much do we go along for every unit, so how much do we go down or up for every unit we go along? Well, if we go from this point here to this point here, we can see that we go along 1 and we go down 6. Careful of the units. 6, 4, 2, 1. We're going to go down 6 for every 1 we go along. So a change in y over change in x is minus 6 over 1, so it gives us minus 6. And it intercepts at 6. So the gradient, the equation of that line is y equals minus 6x plus 6. Now we've got our equations of the boundaries. Now we've got to work out the regions. Well, this one is quite straightforward here. This one we want below y, so therefore y is less than 6. Notice I don't put an equals because we have a dotted line here. Now this one I want to be below x is 2, so therefore x is going to be less than or equal to 2. Notice I put a less than or equal to because I have a filled in line. There's no dotted line here. Now I want to work out this region. So pick a point in the region and see what we get. So we got the point 1, 2 is in the region just here. So let's put the point 1, 2. So you get 2 minus 6 times 1 plus 6. Now this all becomes 0. Minus 6 plus 6 is 0. So which way round should we put our inequality? Well, this way round makes it true. So therefore it's going to be y is less than or greater than or equal to minus 6x plus 6. So let's put them all together. That's 1. There's the other, one other, and the last one is y is less, no, not y, x is less than or equal to 2. Right, next question. A couple more to go. Draw a circle where x squared plus y squared equals 16. This is the key value here. Okay, that is equal to the radius squared. Okay, so the radius squared equals 16, so the radius equals 4. If there's no other values on this side, then it has a centre at the origin. So we want a circle, radius 4, centre of the origin. So I'm going to have a go at drawing a circle. That's radius 4. Does that look like a circle? It's not far out. I'm going to move it so it centres in the middle. Just grab it. It just needs making possibly slightly bigger. I knew you'd use a compass to do this. In fact, there's one problem with this. My graph paper's not square, so therefore it doesn't quite go. So you basically get a circle that's radius 4. You'll use a compass and you'll have graph paper that is square rather than mine, which is not square on my screen. Right. Jack is filling a container with water. The graph shows the depth of the water in centimetres t seconds after the start of filling the container. Calculate and estimate the gradient when t equals 15. So t equals 15 just here. And we want to calculate an estimate of the gradient. So what I'm going to try and do is draw a tangent at 15. And I've just got to move that line slightly so that it does form a tangent at 15. So that's not a bad tangent at 15. Now, you won't be expected to get this exact. You'll be expected to it's going to be an estimate. Okay, just say the word estimate because you're drawing an imperfect tangent. Anyway, so let's start at 2 and try and work out another nice value that we can intersect at on this line, and we can intersect at 3 here. So if we draw that down, create a nice little right angle triangle. So that distance there is 1, and this distance here is 5. It's going to be that's going to be at the point 12, isn't it? So that distance there is going to be 7. So our gradient is going to be roughly 1/7. And what you could do is you could take from this point to this point if you wanted something a bit more accurate would be better. It doesn't really matter. We get the gradient equal to 1/7. So let's just get, if you don't know what 1/7 is, we do 1 divided by, new line, 1 divided by 7, and you get 0.14. I wouldn't go for anything more than 2 decimal places. 0.14 be my answer here. Describe fully what your answer in A represents. So the depth of water in centimetres 1 seconds after the start of filling the water. So it's the rate at which the container is being filled. And that's going to be in centimetres per second. Okay, so it's the rate at which the depth of the water. So the rate. So we could write. So better be more precise. Rate that the depth of the water is increasing. Because actually just saying the rate at which the container is being filled, well, it could be volume. We're just looking at depth here. So it's just the depth of the water is increasing, and this is going to be it's going to be about 0.14 centimeters per second. Okay, 0.14 centimeters per second. Explain why it's only an estimate, because the tangent is hand drawn. Is hand drawn. Okay, and it's quite possible we could end up with tangents all like this, and you can see that there's quite a degree of variance between those two answers. Right, let's move on to this little functions question to finish off for today, and then there'll just be one more series to do to finish all these questions to get up to the 52 questions. We've got the functions f and g of x are given by this. Calculate g f of 3. Now the way to think of this is g of f of 3. Okay, so you've got to do f of 3 first. So f of 3 is equal to 8 minus 3 times 3, which equals minus 1. And now we need to do g of minus 1, because that's g of f of 3. F of 3 is minus 1. And that equals 4 times minus 1, so we get minus 4. Find the inverse function of x. Now there's lots of ways to do this. You could do it, this one's so simple we could do a flow chart, but I'm going to show you a more foolproof method for all types. I'm going to let y equal 8 minus 3x. Now I'm going to make x a subject. So therefore y minus 8 equals minus 3x. And I'm going to divide both sides by minus 3. So I'm just going to grab all this actually. Move it over here. Actually, over here. I don't want to ruin up the get this in the way here. So I'm going to get y minus 8 divided by minus 3 equals x. Now I don't like this minus 3 on the bottom, so I'm going to times every single number by negative 1 to make it a different sign. So I get minus y plus 8 over 3 is equal to x, and it's probably better still to write it as 8 minus y over 3 equals x. You'd be okay. If you're not sure about doing that, leave your answer as this. Okay. Now to get the inverse function, we always write everything back in terms of x. So we write 8 minus x over 3. So f minus 1 of x is equal to 8 minus x over 3.